Problem number 4. A spaceman of mass 80 kilograms is sitting in a spacecraft near the surface of the Earth. The spacecraft is accelerating upward at 5 times the acceleration due to gravity. What is the force of the spaceman on the spacecraft? Solution. To solve this problem, we need to use second Newton law. This is our equation. The ma equal normal force minus force of gravity, because normal force acting up and the gravity acting down, and acceleration equal 5g. So from here we can find what is normal force. That will be this one. This is normal force which is acting from a spacecraft to spaceman. But with the same force he is acting on a spacecraft. And the solution is A, 4,800 newtons. Problem number 5. 3 equal mass satellites A, B and C are in coplanar orbits around the planet as shown in the figure. The magnitudes of the angular momenta of the satellites as measured about the planet are LA, LB and LC. Which of the following statements is correct? We have to choose one of 5 of these statements. Solution. Let's check this picture. We have to write definition for angular momentum. That's this one. Angular momentum equal mass multiplied by velocity and cross product with the radius vector to this satellite from planet. But when vector of velocity and radius vector perpendicular to each other, we can use this equation. And here we can check what is the difference between orbits of these 3 satellites. So first satellite A, it has a circular orbit, and let's compare this angular momentum with the momentum of B satellite. In this point, this satellite B has less velocity than satellite A and same radius vector. It means that angular momentum greater for satellite A. All angular momentum they are conserved, so it doesn't matter where do we measure it. So we just established a first relation. Now let's compare angular momentum of satellite B and C. But now we can choose this point. In this point, velocity of C it's related to circular orbit of this C satellite, but B satellite has a greater velocity because it's the orbit is going by ellipse, which is greater than this circle. It means that angular momentum for B greater than for C. And we can just write this relation that LA greater than LB greater than LC. This is the answer. Problem 6. An object is thrown with a fixed initial speed v0 at various angles alpha relative to the horizon. At some constant height h above the launch point, the speed v of the object is measured as a function of the initial angle alpha. Which of the following best describes the dependency of v on alpha? Assume that the height h is achieved and assume that there is no air resistance. A. V will increase monotonically with alpha. B. V will increase to some critical value Vmax and then decrease. C. V remain constant independent of alpha. D. V will decrease to some critical value V minimum and then increase. E. None of the above. Solution. Here we have energy conservation. So it means that it doesn't matter which angle we will use here, because the energy is conserved, and we have a formula V square equal initial V0 square minus 2gh. And in this formula, the speed on height h does not depend from angle. So solution will be C. V will remain constant independent of alpha.